Dante Certification Program Level 3. This module covers unicast and broadcast traffic. Address messages give huge flexibility advantages. In a TDM network, there's no requirement to use any form of address because destinations are interpreted by their time slot and nothing more. However, in a packet switched network, the addressee is unique. It's also possible to send unsolicited mail from a sender to many or all addresses. Now, this is both very useful and potentially irritating and bad at the same time. IP networks are very good at dealing with limiting these unsolicited mail through management techniques. There are three types of messages in an IP network. These are unicast, one-to-one communication, multicast, which is one-to-many communication, and broadcast, that's one-to-all communication. By contrast, a TDM network is only really unicast, but through wiring tricks it can be made similar to broadcast. Either way, there's no strict distinction. Let's look at how the first type of messaging, that is unicast, works. Each one of these sessions in this example is unicast and are private conversations between the source and the destination. As you can see, a session starts as each device sends a message. The second type of message we will look at is broadcast. As we had already indicated in previous levels of this course, broadcast is one-to-all communication. IT managers, however, tend to be hesitant about using broadcast. Why is that? Let's take a minute to answer that question. A key feature of Ethernet or MAC address to MAC address communication is that an Ethernet frame is able to be sent to a broadcast address. This is an essential function for data networks, but it's not without its drawbacks. A broadcast message floods throughout a network. On Ethernet switches, the destination MAC address will send this frame out of every single connected interface. Pay attention to this small network. We will issue an ARP message. One device responds, all others receive but ignore that message. We'll only have to send a few of these ARPs and everyone will have discovered each other. But what happens when the network gets bigger? Because every device is potentially capable of creating broadcast frames and every switch will flood broadcast frames, it's entirely possible that the amount of broadcast traffic will at some stage be significantly large enough to slow the whole network down. Picture a scenario like this. A broadcast message is sent. All devices hear the message and ignore it as it doesn't interest them. One device, however, listens. Another broadcast message is sent. The same thing happens. One device responds while the rest hear the message and ignore. Again, another message is sent and the same thing happens. You can see the issue with this. This is one reason IT managers are nervous about using broadcast messages in their networks. Broadcast messages can potentially clog up an entire network. But there's a way to resolve this issue. We will discuss that in a different module. Now, we've come to the third type of messaging, that's multicast. Multicast traffic is between unicast and broadcast style communication. Multicast is one-to-many type communication. When multicast is managed by network infrastructure, it's a powerful tool. We dedicate a complete section to multicast in this course. Be sure to check that out.